So now that we completed the orthographic projection portion and we got used to how things look in different orientations from top view, front view, and right view, we are now adding details. Every detail that we add, we start getting into more technical terms, like using technical drawing as an example. So the orthographic projection is just a 2D view. But once we add our dimensions and annotations, we are creating a technical drawing, something that's used to communicate with someone else on how something is built or made. The more details that we go into, we are then starting to create a detailed drawing. Detailed drawings could be multiple technical drawings put together. It is something that just shows as much detail as possible. So it could be more than one view, something with all annotations or notes, dimensions included, sections included, assemblies included, exploded views included. Now, things like that are usually found in a very common product called IKEA. IKEA always has furniture where when you put together, it'll show you something or display where a screw goes or where a part attaches to another part. That drawing would be known as your exploded view because it's showing me the different pieces separate from one another and how they are connected together. The assembly view would be a drawing when it's already connected. So in this case, if we're doing a shelf or a cabinet, it would show me what that shelf or cabinet would look like when it is fully assembled. We are going to continue in the next phase to go into more detail on our section views so that we can see what's actually happening inside our object. This will help us figure out what it's made of and how it's made. So let's begin with what is a section view. A section view is a view that's going to show the inside of an object. This view is going to consist of cutting plane lines as well as section lines. The cutting plane lines are going to be lines that have arrows, a long line, a short dash, another long line, and then another arrow. It is also going to have letters at the end of these arrows. Those letters are going to coincide with how the section view is labeled. Section lines are given right here. Those are lines that are parallel and are going to indicate the material of an object. The spacing is very specific. The spacing is going to determine the density of that object, and the line type is also going to determine the material of that object. If you notice, none of these lines are parallel to the object line. They're all going on an angle, but they are parallel to one another. Even if you notice over here in the triangle, they are never going to even be perpendicular. They're always angled to the object line. So it's very important that when you're creating a section view that you include both these cutting plane lines into the object as well as in the section view itself, include the proper section lines and how it's supposed to be oriented. Once again, always angled. It could be closely tight to one another or open, separated from one another. We use these because we want to see the inside of an object. We want to determine what's a hole and what the tool that's actually cutting through that object would be touching if there was a saw that cut through the object on that line. This is also helpful because if I have a hidden line that I cannot dimension to prior in other views, this opens it up so it turns that hidden line into that object line that I do need to dimension to. Now that we introduced what a section view is, let's create it using this drawing over here. So I'm going to first draw the top view, the front view, and then our right side view would be the same as our front view, so I'm actually not going to keep that there. I'm going to erase that, and I'm going to create a section view in that orientation. So I'm going to put my cutting plane line, and now I'm saying that I will take this part and I will rotate it so that it's looking at you. And I'm going to align it with the view that it would be at. Underneath that view, it's now going to say section, and then I'm going to label the cutting plane line. And the cutting plane line is now labeled A, so it's going to be section A. And since this is wood, my lines are going to be decently spread apart, but they're going to be consistent and parallel to one another. So that is showing you that that object right there is a solid object. You can even change the orientation. So if I was to do a cutting plane line from here and label this B, the front view would then turn into my section BB. Once again, note that I'm not doing it right now, but that would replace and be in the same location as the front view. So that would be here. And then I could draw my section views, my section lines as well. Another view that I could use is a section view here. So that would be, say, CC. And then this time, that would make the top view a section. So once again, I'm going to represent that over here. And that would be section CC. But that same concept as the other views. But the location of this one, once again, would be right above where the top view would be placed. So just to clarify, if I was to create a section view of the front view of that object, that's what it would be like. And notice my arrow direction. If I was to create a section view of the top view of that object, notice I don't need that right side view because all the information I need to make that object is given with these two views. And then if I made a section view of the front, but then I changed its orientation for the top view, this is also what I'd be seeing. The following image that we have in this section right here is showing me all the views that I need. But if I was to manufacture this, instead of getting this piece of metal already created, I would be getting technical drawings. And that's what we're going to begin making right now. Here's an example of the technical drawing you might see. Notice I have a lot more hidden lines in this object, and I want to make those something that I could dimension to, as well as see what's happening on the inside. So we are going to adjust these drawings and include section views instead. So this is the drawing with the same section views. So instead, as you notice, I replaced the front view with a section view. And I included all the section lines. The center lines are still present, dimension lines are still present, and I tried to include every possible dimension that I possibly would need for anyone to recreate this, such as the angles, the placement of each hole, not only from left to right, but from top to bottom, or the height or depth of it. As you can see that the holes right here are going to be completely through the object, as shown in the front view. The hidden lines are also identified in the right side view, just to show you that you can still see the holes represented in that view. So just as a reminder, the cutting plane line is going to look like this. It's going to have arrows, letters, long, short gashes. Section lines are going to be parallel and on an angle. And the section view is going to indicate what cutting plane line is linked with the view itself. So now it's your turn. Notice I have a standard coffee mug here. Granted, mine says my name on it. You're going to find a basic coffee cup, and that's what you're going to use your dimensions for. You're going to create an orthographic projection of that standard coffee cup. Try to keep it as close to what my coffee cup looks like. Make it a technical drawing. Add dimensions, your center lines, and add an annotation of what the material is that makes up that coffee cup. To increase its detail and make a detailed drawing as best as we can, you're going to create a section view of your coffee mug to show how deep the hole is and how thick the ceramic is. Now, to show this, it's not only going to be used with section lines, you're also going to have to dimension it. Keep that in mind. All right, good luck. Let's see what you got.